The engine generates the power to drive an automobile. It is equivalent to the heart in the human body. The engine is also the heaviest part in a car, so its placement greatly affects the driving quality and characteristics of a vehicle. Most cars today have engines installed in the front. The size of the engine and its relationship to the powertrain determine whether it is positioned horizontally or vertically. Other engine types and placements are determined by the number of cylinders, the inline engine, the V engine, and the horizontally opposed engine. Other types include the rotary engine. The most common type of engine is the four-stroke gasoline engine that repeats the following four steps: intake, compression, power, and exhaust. Also using a four-stroke cycle, the diesel engine runs on diesel fuel. Unlike gasoline engines, diesel engines use spontaneous ignition without a spark plug. Today's diesel engines use the Common Rail Direct Fuel Injection System that features an electronically controlled high-pressure pump that injects fuel into the cylinders. This technology greatly reduced black soot and smoke from the exhaust. As highly efficient engines, the Common Rail diesels are quickly regaining popularity. The engine holds the valvetrain, such as the cam, in its cylinder head area. The heart of the engine block, houses the piston, surrounded by covers and the oil pan. Let's take a look at the inside of the engine. This is a four-stroke gasoline engine. We will show you step by step how each part contributes to generating the centripetal force that drives the car. First, the most fundamental components are the cylinders and the combustion chamber located here. The valves open and close, sending the intake of air-fuel mixture into the cylinders. The lifter that is attached to the camshaft controls the opening and closing of the valves. To drive the camshaft, the chain and the timing belt help relay the rotations of the crankshaft, of which function we'll explain in a moment. The air-fuel mixture is compressed in the combustion chamber and ignited by the spark plug. Power of the combustion pushes down the pistons. The piston compresses the air-fuel mixture and contains the combustion. The mechanism is a two-part set made of the piston and the piston ring. The piston ring seals the combustion chamber while minimizing friction during oscillation. Mechanics, thermal engineering, chemistry, materials engineering, mechanical engineering all come together in this seemingly simple part. The crankshaft converts the reciprocating linear piston movement into rotation via the connecting rod. The term engine revolutions per minute refers to the crankshaft RPM. The crankshaft vibrates vigorously during operation. The balance shaft offsets the vibrations to restore engine balance. The flywheel connects to the crankshaft, reducing fluctuations in the rotational speed. Its moment of inertia helps maintain steady rotations. The flywheel also helps start the engine by compressing the air-fuel mixture and providing the power to activate the piston. Opposite the flywheel is the crank pulley, which rotates the camshaft. The cylinder head contains the camshaft and the valves. Having complex configurations, the cylinder head must also be lightweight. Engine performance is heavily dependent on this part. The head gasket is used to improve the seal of the cylinder head. The piston, connecting rod, and crankshaft all reside in the cylinder block. The oil pan stores the lubricant for the engine. The side covers encase the oil pump and the water pump. Covers are made of lightweight materials such as plastic and magnesium.